Okay, so the time now is 7:19 p.m. 7:19 a.m. So, I just woke up not too long ago. We will start off early today because today is going to be a long day ahead, but got quite a few things to do. Going to be going through Lead Code Easy just for the sake of speed and clarity. So I'll set a time of 20 minutes for myself to finish, and we'll see if I can explain everything. So this is the question. Maximum depth of a binary tree, pretty straightforward. Given the root of a binary tree, return its depth. The depth of a binary tree is defined as the number of nodes along the longest path from the root node down to the farthest leaf node. Okay, so 1, 2, 3, null, null, 4. So this should be depth first search. And the recommended time and space complexity is ON and ON. So likely what happens is we can do a DFS. So DFS approach, no queue. So DFS approach, SQ. All right. So BFS is pretty straightforward. You just keep looping. Every level that you so-called process is +1 to the depth. And until the queue is empty, you just keep processing. So in this question, I think I might actually try the DFS approach.
Oh,
Okay. So the DFS approach is if I go left, so looking at base case, right? If no root, I'll return 0. Then if no root dot left, but there is a right root, I will return uh 1 plus this dot max depth of root dot right. So this is because if there's no left node, I will have to find the current level plus the max depth of the right. So if there is a, let's say the right node, okay, wait, hold on. So if it doesn't have root dot left and no root dot right, turn 1. So these are two base cases. If there's only one node in a tree, or if there's no node, you return 0 because there's no tree. If there's one node only, by default it's 1. But it can also mean if it's a leaf node, right? This is height 1. And then root dot left will return 1 plus this dot max depth root right. Okay. Then if no root dot right, same thing, I will return 1 plus this dot max depth root dot left. Okay. So these are in the event that is only one-sided. So let's see. In this case, there is everything. So you have to find the maximum of 1 plus left or 1 plus right. So in this case, we'll return math.max 1 plus 1 plus this dot max depth dot left 1 plus this dot max depth root dot right. So in this case, let's just give it a run and see how it goes. So far, the cases work, so I'll submit, and I managed to do it, beat 100%. So time and space complexity is pretty much just ON, because ON for space complexity, because the number of times we will call this dot max depth is dependent on the number of nodes. So space complexity equivalent to number of nodes this dot max depth has to visit. And time is actually equals to ON. It's equals the same thing, number of nodes processed once. Either return 1, 0, 1, or recurse. So there's only one procession. You either return 0 or you return 1 or you recurse. So this is a pretty straightforward question. And I didn't read this question beforehand. I didn't check any hints. It's the first time I saw this question. And I guess at this point in time, I can do another easy question. So if it's the same tree, we can do this is probably, well, I think maybe we'll save this for another day. I gotta go prepare for something. So this will be it for today.